Okay, let's go ahead and go over some rules of probabilities now that we know how to define a probability. All right? All right, first things first. We know that the probability, let's see, of an impossibility, in other words, the probability that I flip a 3 on a standard head is equal to 0. The probability, excuse me, of a certainty, all right? In other words, say the probability that I flip a head or a tail on a regular old coin is 1. And the probability of any event is always going to be wedged between 0 and 1. All right, those are the biggies right now. I know the probability of an event, because think about it. If I also remember, the probability of an event is equal to the number of ways the event can occur divided by the number in the sample size. In the sample size, all right? That's this, or it's also referred to as the sample space. So this guy is always going to be bigger than this guy, always, unless they're equal, which they could be. Okay. Now let's real quick. Let's talk about the complement of an event. Whatever, meant of an event. An event. And we've got a notation for this. And I'm going to use a Venn diagram. This is referred to, this is equal to the complement of E. Venn diagrams are the easiest way to show this. All right? Check this out. Let's say that this is the sample space right here. This is my sample space. Okay, so it's the set of all the possible outcomes. And let's say that E lives over here. All right? The complement of E is everything that isn't E. All right? E complement, bless it, that just doesn't want to write on it, does it? E complement is all this stuff over here. Now, there's a really powerful little rule that we can pull out of that. If I take the probability of an event and I add that to the probability of its complement, what does that absolutely have to be? Well, think about that. The number of ways that the event can happen plus the number of ways that the event can't happen constitute the entire sample space. And if I take the number of elements in the sample space and divide them by the number of elements in the sample space, I always get 1. Okay? Now, that's just a real general introduction to probability. Now, what we're going to do here, I'm going to throw a little something else at you, especially since we're in Reno. You may or may not be from Reno. Pardon me, I'm going to take a drink real quick. But we're going to talk about odds. And the reason we're going to talk about odds is because so many people screw them up. All right? Odds, first things first, not probability. Probability. They're not probability. I cannot tell you how many times I've had somebody say, yeah, the odds of something happening are 50-50. Or the odds of rolling a 6 on a 6-sided die is 1 in 6. Incorrect. The probability of rolling a 6 is 1 in 6. The odds of rolling a 6 is actually 5 to 1 against. You could also see this written as 1 to 5. This is against, and this is in favor. Whoops, favor. Okay? Now, the odds of an event is typically written as a ratio, and it's the number of ways the event can happen as a ratio to the number of ways the event can't happen, or the complement of the event can happen. That's why complements are introduced in this textbook. Now, let me explain what that really means. Odds are there for one reason and one reason only, period, for gambling. I don't care where else you hear them. The whole purpose behind odds, because if you think about it, it's just a little tweaking of the definition of probability. The whole purpose for odds, excuse me, is so that casinos know what to pay. Now, I'm going to go up on a little soapbox here, so bear with me for a sec. This won't take much time at all. Let me explain how odds work. In a fair game is defined as a game where if you play the game over and over and over and over again, nobody wins any money. The house doesn't win any money, and the player doesn't win any money. So you may win on some games, on some individual games, and you may lose on some individual games. But if you play a bunch, if you let that law of large numbers go into effect, nobody's going to win any money. It all comes out even. Okay, so let's think of this. Let's roll the die real quick. Let's play a game called Roll a Six. Okay. Now, again, the probability of rolling a 6 is 1/6. I'm going to write this again. The odds of rolling a 6 is the number of ways to roll a 6 is 1. Okay? And the number of ways to roll a not 6 is 5. All right? Notice, the odds, this ratio always adds up to the size of the sample space as long as the ratio hasn't been simplified. Let's be real clear about that. Now, what this means is, if I am running a fair game, so let's assume that roll a 6 is a fair game. If I bet $1 and I win, the house pays off $5 plus I get my bet back. That's in a fair game. Okay? That's how odds work. Let's say we were in a game where the odds were, let's see, 150 to 1. 150 to 1. That means if I win and I bet $1, then I get $150 plus my $1 bet back. If I bet $2, then I get $300 plus my $2 back. Now, people often think that casinos somehow cheat. That's not true at all. I'm going to dummy this way down. I hope that I'm not patronizing anybody, but think about it this way. What a casino does is it simply doesn't pay true odds. In other words, in my game of Roll a 6, clearly a casino doesn't have a game this simple, but pretty close. In the game of Roll a 6, if I win, they wouldn't pay me my full $5 back, plus my bet back. They may pay me a total of $4, which really means that they're giving me 1 to 3 odds, because remember, there's my $1 bet. So if they hand me $4 back, that means they gave me $3 plus my $1 bet back. That guarantees that over the course of many, many, many plays, the casino, even when they pay out, they're actually making $2 over true odds. And that's what true odds are. Okay? Those are what are referred to as payout odds. These are payout. Whoops. I'm sorry, I should have pointed to that. These would be payout odds, and these would be true odds. So these are true, and this is what the casino might pay out on. And that's how the casinos make a lot of money, keep their lights on, and employ a bunch of employees. All right. I hope that was helpful. We'll play around a lot more with probabilities. They're a good time. Thanks for paying attention.